Okay, so number 11, it says write the equation of a line that's parallel to y equals negative 3x plus 2 that passes through the point 3, negative 2. So the first thing you want to focus on is it says parallel to, and it gives us an equation which is y equals negative 3x plus 2. What I want to get from the equation is the slope, and the slope is simply the number in front of x. So when I'm looking at a linear equation, y equals everything else, the number in front of x matters to me. So the slope of the line they gave me is negative 3. I want the equation parallel to that line, so the slopes are going to be the same, y-intercepts are different. So this plus 2 doesn't really matter what that number is. I don't care about that number. This is the only thing I care about. Once I get that information, this equation no longer is of use to me. The other thing I need to know is the point that the line I care about passes through, and it says it passes through the point 3, negative 2. So that's the information I want to get from the problem in order to work this out. Once I have that information down there, I know that y equals mx plus b is the structure that I'm looking for to create a linear equation. Anytime I just write the equation of the line, that's what a line equation looks like. Well, m is negative 3, that's this thing. X is 3, that's this thing. And y is negative 2, and that's this thing. So those three values have specific numerical values that we can replace. So we do that replacement, negative 2 equals negative 3 times 3 plus b. And then we have an equation that b is what we're looking for, everything else is numerical. So negative 2 is equal to negative 9 plus b. I usually multiply first to verify that's going to be an integer. Kind of saw ahead of time it was going to be, so I didn't worry about it. If this happens to be a fraction, we want to make this a common denominator on this side. In that case, it doesn't happen though. The 9 moves over, becomes plus 9. Negative 2 plus 9 is 7. And once I know what the slope and the y-intercept are, that's exactly what I want to put in my equation every time. So, once I figure out that m is equal to something and b is equal to something, which I did here and here, I'm ready to write the answer. So in this case, y equals negative 3x plus 7. Now be cautious that your final equation has a y equals to it. Make sure the slope is attached to the x. A lot of times people forget the x and the y. That makes the answer wrong if you don't do that. Okay, problem 12. Kind of the same type of problem. Only difference here is asking for the perpendicular line. But once again, they gave me the equation of a line. Y equals negative 3x plus 2. And the number I care about in that equation, again, is my slope. So negative 3 is the slope of this equation. So m equals negative 3. But since they're asking me for the perpendicular, not the parallel, perpendicular slopes are opposite reciprocals. So if the slope of the line they gave me is negative 3, the perpendicular slope is going to be positive 1/3. We change the sign and we flip the fraction. 3 over 1 flips over to 1/3. Once I create the perpendicular slope, I throw out the original slope. It no longer matters at this point. The other piece of information I need is that what point the line passes through. The line I'm passing through happens to go through 3, negative 2. So I do that. And once again, I'm at the same point where I know m, I know x is equal to 3, I know y is equal to negative 2. Y equals mx plus b is the structure of my linear equation. I'm going to replace these three values, mx and y, in this equation. So y is negative 2, m is positive 1/3, x is positive 3. 1/3 times 3 is equal to 1. I want to know 1 plus b is equal to negative 2. I slide the negative 1 over. It's 1 becomes negative 1 on the left. Negative 2 minus 1 is negative 3. My y-intercept is negative 3. My slope is positive 1/3. My structure is y equals mx plus b, replacing m and b with the values I just found. So y equals positive 1/3 x minus 3 would be the equation, perpendicular to that line that passes through 3, negative 2.